Welcome back, dear learners. Today is the second lecture for Unit 2, that is Constructs of C. Today we are going to discuss what are data types, what are variables, and identifiers. Before we begin with today's class, let us have a brief recap of what all was done in the previous lecture. So we discussed about the history of C, what are the various features that make C so popular, where all it is used, what is the basic structure of a C program, and then we did a Hello World program which we called the greeting program to print a Hello World message onto your output window. So that was just the basics. Now we need to get into the technicalities of the language. And so the objectives for today's class is what is the process of writing a C program? Like we already wrote a hello world statement, right? But now what happens when we start to compile it? What happens when we want to run it? So we will look at all those steps that are happening when we are actually trying to execute a program from the stage of writing it until getting the desired output. Then we will look at the C character set. What are tokens? What is the meaning of keywords, identifiers, variables, and constants? And then briefly we'll discuss what data types in C are. So the steps for creating a C program. So if you remember in the last lecture, we wrote some code where we had used a function printf to print a message, hello world, right? Now that code is a source code file and you save it with an extension .c. Just like you save your PowerPoint presentation with .pptx or your Word documents with .doc or docx extensions. So similarly, a C program has an extension .c. That is how the compiler knows that this is a C program, right? If you talk about some other languages like C++, so there the extension is .cpp. But since we're talking about C language here, the extension to our source codes or the whatever code that we write in C, when we're trying to save that file, we are going to save it as any name that you want to give to a file, any valid name .c. Now remember, there cannot be spaces in between the file names. Suppose I want to save a document or a source code as hello world.c. That's the name of the file, right? So there cannot be any space between hello and world. So it has to be clubbed together, hello world.c. .c is the extension, right? So you write the source code and you save it as .c file. Now you want to pre-process the source code according to the preprocessor directives. Preprocessor directives were the hash, right? And what was happening here is we were trying to incorporate all the libraries that our source code is going to use, right? So we want to compile this pre-processed source codes into object codes, right? Then we link the object file, the compiled object codes, with other object codes and the library object codes to produce an executable exe file. See, so once you're compiling, you get an extension as .obj and then the linking happens, which enables your compiled file to get a proper environment where it can run, right? So that is a .exe file, right? Then once that exe file is ready, you can load it and you can run it on the computer. So those are the steps. So you open any editor or you open any IDE. It could be an online editor or it could be a notepad file, and you write your source code and save it as .c. In the pre-processing stage, what happens is your preprocessor directives, that is all the header files that would be needed are included, right? And then the compilation starts. Now after the compilation, you get a .obj file, right? So the extension, now you have a new file in the folder with an extension as .obj. It's going to be the same name as that of your source code, but just have an extension as .obj instead of C now, right? So this is an object code. This is an intermediate code, right? Now after this, all the linking happens so that this object code can be converted into an executable file with a .exe extension. So that happens, and after this, you have a loader where you can load this .exe file and you can run it on your CPU. You can give any input from the user and you can get the desired output, right? So source code then building of the file, which includes the compilation process majorly, and then the linking, and then the running part. You're loading your executable code onto the memory so that it could run, right? So those are the basic steps for creating a C program. Now, what is a character set? Now, whenever we talk about any language, whether it is English, whether it is Hindi, whether it is C, C++, Java, you always have valid set of characters which are allowed to be used in that particular language. Say, for example, if I'm talking or I'm writing in English, now I obviously cannot use the Hindi alphabet in English, right? I cannot use a in my English language. Similarly, every language has its own character set. Now, in C, when we talk about its character set, it is comprised of the alphabets, the digits, and some special symbols, right? So, valid character set for C is you have alphabets A, B, up to X, Y, Z, right? All those 26 letters in uppercase as well as in lowercase. Then you have digits from 0 to 9, and you have these special symbols. Special symbols are all those symbols like exclamation mark, question mark, brackets, curly braces, backslash, forward slash, minus, plus, division, operators, right? So all those symbols are categorized as special symbols, right? So now one thing that you must always and always remember is that C is a case sensitive language, and that is why capital A is going to be treated differently as compared to small a. So if I'm writing ABC in caps versus ABC in lowercase. So both of them are going to be different. Point to remember always that C is a case sensitive language. So this makes a character set. The alphabets, the numbers, and special symbols, when properly combined, form concept. We're going to just start with the first thing, which is the keywords. Now, keywords, as the name suggests, that they have some key meaning, right? What is specific here is that when you use some keywords, the compiler already knows what its meaning is. So you don't need to tell the compiler, hey, I'm declaring this and this is what it means. The compiler already knows the meaning of these keywords. So they are also called as reserved words. Why? Because you cannot use these keywords as your variables or identifier names, right? In C, there are 32 keywords, and these are all given here: auto, break, case, char, const, continue. And as we go and proceed into the course, you will see that we are using almost like most of them will be frequently used, like int, long, char. These are data types and they are frequently used. Without them, you will probably never be making any program. So keywords means that the compiler already knows what the meaning of these words is, right? So you don't need to explain to the compiler what it is going to do. It already knows the meaning. So and you cannot use these variable names, right? Now, um, proceeding on, identifiers and variables. See, identifiers are the names given to anything for the purpose of identification. Like I have a name, Varsha. You might have your name, right? Everything has a name. That is how we identify things, right? So identifiers are just the same. Whether you're creating a function and you're giving it any particular name, or you're creating a variable, or you want to give a specific name to a memory location. All these are identifiers. An entity that may vary during the program execution is a variable, and variable names are given to locations in memory. Suppose I want to add two numbers, right? And after adding these two numbers, I want to store the result somewhere. So where will it be stored? Obviously in the memory. But do I need to know the particular address of that memory? No, it is going to be very tough. Suppose if every memory is can be identified by a number, then I will need to remember these numbers. See, that is always going to be tough. So what I want to do is I want to give it a particular variable name so that it is easy for me to identify which particular memory I want to use or refer to, right? So those are the concept of variables. So you are giving names to memory locations. Just like understand it as each house in a city has a address, right? So similarly, every memory location has an address, but it would be very tedious for us to know those memory locations because it is going to be in terms of some numerical hexadecimal values. So instead of that, what we are trying to do is we are trying to give it some user defined names, right? So a variable name can be given to any location in a memory. Now, there are certain rules for declaring these variable names as well as identifiers. First is that the length of these names should rather be at max 31 characters, right? Second thing, that it should either start with a character like an alphabet or underscore, right? So you cannot name a variable as 123 ABC. Why? Because it is starting with a digit. So it can either start with an alphabet or underscore. So I can have a name like gross salary, or I can have underscore gross salary. So it can start with a underscore or it can start with a alphabet. Secondly, there cannot be any spaces or commas in between your variable name, and also no other special symbol can be used, just underscore. Like here I've shown gross salary, right? So you have gross salary. These are two separate words, but since I'm not allowed to use a space in between them, so there's a convention of using an underscore to separate the two words and avoid confusion. So a variable name always has an associated type with it to identify what kind of value it can store. See, I'm trying to store some values in my memory. But what kind of memory value it can take, that can be identified with the help of data types, which we'll be looking at in just a brief while. So a variable always and always have an associated data type. Now, next is constants. See, constant is anything that does not change, right? So, if I am saying 3, 3 is always going to be 3. But in mathematics, when I say there's a variable x which is equal to 5, I can still replace that x with a new value, say minus 5 or minus 10. So, that is why they are called as variables. Constant, they remain same, right? So, 3 is always going to be 3. 10 is always going to be 10. So 10 is a constant, whereas a variable is anything whose value can keep on changing, right? So a constant does not change during the execution of the program. We have various types of constants, like we have integer constants, we have character constant, we have real constants. We'll be looking at them one by one, what they are. So, an integer constant. So we all know what integers are, right? Integer is any positive or negative value, right? But it cannot be decimals. It is a whole value. So, when we talk about integers, so 426 is an integer, plus 765 is an integer, minus 7606 is an integer. So all these numbers are integers. They can be positive as well as negative. But one thing to remember is that every integer for every compiler has a specific range. So if I'm talking about a 16-bit compiler, then the valid range for an integer constant can be from minus 3 to 768 to 3 to 767. It varies for 32-bit compiler. So what is happening in between here is that this 16-bit compiler stores an integer value in 2 bytes, whereas a 32-bit compiler would store an integer in 4 bytes. So there are more number of possible combinations for a 32-bit compiler, and hence the range increases, right? But when I'm talking about a 16-bit compiler, so the range is from minus 3 to 768 to 3 to 767. That is 2 bytes. Now, by default, an integer, if I'm not putting any sign, like here I have 4 to 6, right? But this 4 to 6 does not have any sign. So it is by default a positive integer. If I don't put any sign, it is a positive integer. This is also a positive integer because I have explicitly put a positive sign in front of it. This is a negative integer, right? Now, what are real constants? Real constants are also called as floating point constants. So now, a real constant or a floating point constant must always have a decimal point. It can either be positive, it can either be negative. By default, it is positive. But you have two ways of representing this real constant. One is a fractional form that you usually use even in mathematics, right? When you have a, say, a number like 32.34. So this decimal, this point, this identifies this to be a real constant. And this is a fractional notation, a fractional form. Minus 21.09 plus 98.12, and if I'm not putting any sign in before the number, then it is by default considered as a positive real constant, right? Whereas the exponential form, you have that mantissa and exponential part. It is similar to your scientific notations where you use an exponent. So here also the mantissa is separated by the exponential part with the e in between. So here in these examples, like plus 3.2, this is the mantissa, and exponent is minus 5. Similarly, here 4.1 is the mantissa, and 8 is the exponent part. Here minus 1.2 is the mantissa, and plus 3 is the exponent part. Now, if I'm not putting any sign, then by default they are positive. So you need to remember this. Like here, this 8 has no sign. So by default, it is a positive 8. Here, 4.1 has no sign. So it is a positive real constant. So you have two ways of, declaring these. It can be a fractional form or it can be an exponential form. Then you have character constants. Now, character is a single digit or a single alphabet or a single special character. Each character constant has an ASCII code with the help of which the compiler actually identifies, okay, this is this particular code. So now if I write a capital A has a set ASCII code which is 65. Small a has a different code which is 97. Now why is this happening is because C is a case sensitive language and capital A is going to be treated differently from small a. So they have different codes. A character constant is in between these single quotes. And please remember, so they are both facing in the same direction. Okay. So a single alphabet digit or a special character within this single quote is a character constant. Each character constant has an ASCII code, and the code for a capital A versus a small a is going to be different, right? Now, what are string constants? See, string constants are between the double quotes. Okay, so if I'm writing double quotes in and I'm writing hello in between, so that is a string constant. Then world here, A, B, 1, 2, all of these are strings because they are in between the double quotes. But if I'm writing a capital A in double quotes and I'm writing a capital A in single quote, so these two are going to be different. Why? Hey, because the first one, the capital A in double quotes is a string constant, whereas the second one is a character constant. So they are different. If I want to check the equality of these two, no, they are not going to be equal. Why? Because one is a string constant, other is a character constant, and character constants are represented by their ASCII codes, whereas string constants are not represented by ASCII codes. Okay, then we have this special character constants. See, special character constants are used to give, special meaning and format the way things are being displayed in the output. So they are used in the output functions. We have a slash n, which is for new line. So I'm printing some statements, and in between I use a slash n. So now whatever is going to follow after the slash n is going to be printed in the next line. So it's a new line or a next line character. Now, similarly, as you use a tab in your, you have a tab in your keyboard, right? What it does, it shifts horizontally by one tab. So if I want to do that in my output, for that I have a slash t. So it will create a one tab space in between the output. You have slash 0, which is a null character. We'll be using them when we talk about strings. But here, if now this is being called as a character constant, and we talk that character constant is a single character. But here we have two. We have a slash, and then we have a either a T or a N or a V or a 0. But these two are together being considered as a single character constant only. So even though they are two characters, they are considered single character. And this particular combination has a certain meaning. Okay, so that's character constant, special character constants. Now the backbone of C, which is data types. See, we all are writing programs to deal with data. We want to work with data efficiently, we want to solve our problems quickly, we want to store our data. So data is the main component, it's the hero. So we want that they should be stored in a proper format so that it is easy to retrieve them whenever needed, and so that there is no loss of information. So for that we have data types. If you look at this diagram here, you will see that data types in C are of two types. You have a primitive data type and you have a derived data type. So data types are needed to inform the compiler about what kind of values can be stored in a particular variable. It gives information like the size of the variable in the memory, the range of permitted values that it can hold, and the type of values that it can hold. So these three information are what are being directed by the data types. You have two types, primitive data type and derived data type. Primitive data type are the basic data types that a compiler directly understands. Okay, and the derived data types, they are extension of the primitive data types, and they are actually being, they are being derived or being created with a combination or with the help of these primitive data types. So in primitive data types we have these four data types: int, char, float, and double. And in derived you can have arrays, you can have structure, you can have union, enum, pointers. So now, what are the primitive data types here is we have char, we have int, we have float, and we have double. Now char is to store character type values, single character. So it could either be ABC in caps or in lowercase. It could be a digit or it could be a special character. But it is one single character only. The range for this is from -128 to 127, and it takes 1 byte in memory. So the format specifier for this is percentage %C. We'll be understanding what the use of format specifier is once we go to a program and we try to print a particular value. That is when it will make more sense. So now, next we have is integers. Now, like I told you earlier also, that integer in a 16-bit machine or a compiler takes 2 bytes. So the range for it is from -32768 to +32767. And the format specifier for an integer is percentage %D. For floating numbers, the range is as given: -3.4. This is E is exponent part, that is raised to power 38, to plus 3.4 exponent 38. It takes 4 bytes in memory, and the format specifier is percentage %F. Now, if this much space or this range is not suitable, and if you are maybe stuck in some scientific calculations and the digits or the numbers that you're working with fall beyond this range, then you have an extension to float number, which is a double. So here the range is increased up to a large extent. As you can see, the exponent part is now raised to power like 308. So that's a huge gap, right? But it also occupies more space. So it's going to take 8 bytes in memory. And the format specifier for this is LF. So you can understand this as long float. So float is being extended to more size so that it has a wider range, and it is used when you're trying to deal with very small numbers or very huge numbers and you're dealing with some scientific calculations, right? So for those things you might need a double value. So those are the basic primitive data types here: char, int, float, double. Now if you see here, I have written all of them in small case, like small key C for char, small I, everything is in small, right? Why is this so? Is because these are keywords, right? These are the keywords, and as we all know, keywords have a specified meaning already that the compiler knows. So here, char is a keyword, int is a keyword, float is a keyword, and double is a keyword. So these have to be in lower case only. All the keywords are always in lower case, all. Okay? So that's the requirement here. Now, let us go to an online compiler and try to write a few data types and see what all how to give values to it. And let us also try to understand the role of this format specifier here. So what you can do is you can go to a browser and you can write this online C compiler. You'll have like lots and lots of options. So I'm just choosing the first one that is here. Now here by default, you might find that the language could be C++. So if that is the case, you need to just look here. This is main.cpp. And as I told you, CPP is an extension for C++ language. I want to work with C. So I will choose C as the language. And as soon as I do that, you will see that here the extension changes to .c. Now we had discussed that this is a multi-line comment that begins and ends with this. So this here, this is a comment and it will not be a part of the compiled code. It is just for the coder or the tester's benefit, right? If you want, you can remove this. Now here, the thing here, hash include. Now I told you hash is a preprocessor directive. So here you are trying to include a standard input output file, right? And that has been included here and have this main. Like I told you in the previous lecture, main is the starting point of execution of your code. It's a function. And since here it is a int main function, so you need to return some integer value. If I make void here, then I don't need to return any value. But for now, let us not focus on the return types and what return is, because we'll be discussing it further when we discuss about functions. For now, let us just remember that this main is a function and it is actually the starting point of the execution of your program. And here is a printf statement. It's a function which is available in stdio, standard input output file library. And what I've done here is I have put this message here, hello world. Now if I try to run this, so automatically it is compiling as you could see, and then it is running this. So now let me move this here. You can see this is the output on the console. Okay, now let us try to make some modifications here. Hello world, how are you? So now I'm expecting this entire message to be printed onto my console. Let's see, it's compiling and then it's executing. And it takes a while because I'm using an online compiler. But yes, you can see that I got the desired output. Now, let us try to create or declare some variables which are going to use these data types that we just discussed. So I am declaring a variable, say number one, and I'm giving it a data type of integer, right? So int is the data type here, and no1, this is a valid variable name. After this, let us make another variable and say number two. So I can do this. I'm doing is I'm using a comma here and I'm writing no2, and then I'm ending the statement with a semicolon. So every statement in C ends with a semicolon. What all I can do is I can also assign them some values here. So I am doing int number one is equal to 10 and number two is equal to suppose 20. I could have written these in separate lines also, like I could have put a semicolon here, and in a fresh line I could have done this as well. So that's fine. I was just trying to avoid writing two times int. So you can do that if you have two same variable with data types, I mean same data type variables, you can write them in a single line separated by spaces. So, and also you can write them in separate lines. So it's your choice. Now I have two numbers here. One is number one, another is number two, and I have assigned some values here. What I want to do is I want to print the sum of these two values. So let me declare another variable, say int sum. We always try to give some relevant names so they are obvious as to what their utility or what their functionality is. So I'm declaring a variable int sum, and then what I'm doing is just remember to put a semicolon after every statement. And I'm writing sum is equal to number 1 plus number 2. Now, though we have not discussed operators yet, but I'm sure this much is intuitive that we are trying to add two numbers. So I'm expecting sum to have a value 30, right? Now I want to print this value 30. I'm going to change the statement here and maybe write the sum of two numbers is, and then here. Now here comes the role of format specifier. I'm writing a percentage D. Now wherever you find a percentage D, it means that here some integer type value is going to be printed. And what is that? Outside the double quotes. So whatever goes in double quotes is printed as it is. So as it is, the sum of two numbers is, and then a colon. This would be printed, and then there is a format specifier percentage D. This is telling you that a integer value is to be printed. Now outside the double quotes, I'm using a comma and I'm using the variable. So sum is the variable whose value I want to print. So what happens is the values of this sum variable will be replaced by into this percentage D. So I'm expecting an output to be of the type the sum of two numbers is colon and then 30. So let us try to run this and see if it is working. It might take a little time because online compilers are slow. But yes, I did get what I was expecting. So I got the result 30. Now, another thing that I want you to try is let us try to put some float numbers here, like maybe some decimal numbers here. What is going to happen now? Let us see. So, what it did here, this brilliant thing did one thing, it just took the integer part of your numbers. So it ignored the decimal and then 0.45 or 0.33 and it just added 2 and 2, right? And then it put it the value into sum and it got printed. Another thing let's try to do is, for example, I'm just going to erase this here, or maybe, yeah, I'm just going to remove this. And let us try to create a character. Char ch. So ch is a variable here, variable name rather, which is of type char. And I'm using, and I want to print this. So what I'll do is, now the format specifier for a character is, and I'm using a percentage C because that is used for characters, right? And I'm going to use ch here. So I'm expecting the character value is and then a capital A. That's what I'm expecting here. So let's run this. And yes, you got the character value is A, right? So that is how data types work. But now if I try to do something like this, say 450.349 or 345, what is going to happen now? So you can try all these cases. You can try and do all these things. And here you get a warning. Overflow. So there's a warning here. Overflow and implicit constant conversion. So you're trying to convert 450 to a character, but the range for character is -1282 plus 127. And this is clearly going outside the range. And hence the code is not working properly. So you need to be careful with data types. You go ahead and play with them. You try something on your own. Try different format specifiers along with your data types. And then we'll be getting into the details of these data types further. So today was just an introduction to data types. We have ways of extending the size of these data types or modifying the range of these data types that we'll be talking in the next lecture. It will be a detailed discussion on data types where we'll be introducing some more keywords like long, short, unsigned, signed, and how it impacts the range of the data types. That's it for today. These are some of the books and the references that I picked the content from. And so, in today's lecture, we discussed what is the structure of a program, as in from the point of writing the source code to running a code. There are in between conversions. First, an object code is generated, which is an intermediate code, and next is an executable code. So we saw all those stages. Then we started discussing about the character set, the valid character or alphabet that is for any particular language, here, especially C. Then we discussed some tokens, like what are keywords, what are variables, what are identifiers, what are constant variables, constants, and so on. And last, we gave an introduction to what data types are and what are its utility. We also saw it in a program. We also saw briefly the use of a format specifier. As we go into subsequent lectures, we'll try to understand more about them. Thank you. I hope you enjoyed today's class. If you have any queries, please feel free to mail me at varshasisodia@gilgotiasuniversity.edu.in. I'll be more than happy to take up